So, good morning, good afternoon, good evening, and good night at the end of this video. So, at Noom Chemistry, we are going to start a proper series of mathematics covering entire mathematics used in physical chemistry and in entirely complete chemistry. We're going to have around 75 to 100 videos in this particular course, and each video will be very small, covering a single topic in a single video. We are going to cover a single topic in a single video, and at the end of each video we're going to provide certain assignments on a Telegram channel, and I request you all to join the Telegram channel and solve those assignments. The level of our course is to understand the chemistry up to intermediate, undergraduate, and postgraduate level. So, the very first video titles Numbers and Units. So, what are numbers and what are units? Numbers are nothing but the physical appearance of quantities. The physical appearance of quantities. Example, suppose you're having certain chocolates. You're having certain chocolates. You're saying you're having these many chocolates. So how you're going to say, like, how many chocolates do you have? So you're going to write 1, 2. You're having 2 chocolates. This 2 is the symbol representing the quantity of chocolates you have. So these are basically the numbers representing the quantities. And there is very infinite existence of these symbols. To understand these symbols, the representation of physical quantities of numbers, we have to understand the types of these quantities, the types of these numbers. The very first is real scalar number. Real scalar number. So what is real scalar number? Real means any number which has its physical quantity or physical appearance or physical existence. For example, 2, 3, 4, 5, 7, 100, -2, -3. Suppose you're having 2 chocolates, you have given those 2 chocolates to me, now you're having 0 chocolates. But I got to know that you have taken those 2 chocolates from someone else. Now you are in debt of -2 chocolates. All these are physical numbers, like you can explain them on physical basis, on day-to-day life basis, or you can express them on number line. These are real numbers. What are scalar numbers? The numbers or the units expressing only the magnitude, for example, how much gram, what is the temperature, what is the volume. It doesn't defines the direction into which these magnitude is going. For example, temperature 30 degrees centigrade. So this temperature is moving towards which side? Or suppose length, which is 10 centimeter. Now this 10 centimeter is now this 10 centimeter justifies only one number and the unit. It doesn't gives you the directions, like 10 centimeter towards north, or 10 meter towards north, 30 degrees centigrade towards north, south, east, west, up, down. You do not have any direction. So if you're having only magnitude and no direction, these are scalar. So the numbers representing the scalar values are real scalar number. Again, the numbers representing the scalar values are real scalar numbers. Now, second thing we have to understand is integers. Integers. What are integers? Integers are negative to positive numbers, including 0, which are not fraction or in decimal format. These are what? These are integers. Now, all the positive integers, including 0, are whole numbers. For example, suppose I'm writing -1, -2, -2 by 3, 0, 1, 2. So out of these numbers, which of them are integers? So -1 is an integer, -2 is an integer, -2 by 3. Nah, no, 0 is an integer, 1 is an integer, 2 is an integer too. and 0, 1, 2 are also whole numbers. So these are integers and these are whole numbers. Second thing, the next thing we have to understand is rational number. Rational number. Now, suppose you're walking on a road, and in your country, there's certain rule that you have to walk on the right side of this particular road. So this road is rational road. Like, to walk on this road, you have to follow certain rules. So the numbers which follow certain rules are known as rational numbers. And what are those rules? We are having three rules of a number to be a rational number, to be qualified as a rational number. And what are these three rules? Rule number one, that all the numbers should be integers. All the numbers should be what? Integers. Rule number second, those integers should be in p by q format. Example, -2 is a rational number, -2 by 1 is also a rational number, 3 is also a rational number because we're having a denominator 1, so is 4 by 2. And the third rule is that the q, which is the denominator, should not be equal to 0. And why so? We have to understand it. Suppose you're having 10 chocolates and you have to distribute these 10 chocolates to 5 people. So 10 divided by 5 is equal to 2. Now this is a very proper physical example, that if you're going to distribute 10 chocolates into 5 people, each of the person is going to have 2 chocolates. And 10 by 5 is also a rational number, 2 is also a rational number. Now suppose you're having 10 chocolates, I'm telling you to distribute it 0 people, then 10 by 0 will be what? An not definable value, which is basically infinity. So you cannot define this number. You cannot define this number. It is a very large number. So we cannot call this number or this number a rational number, because it is not obeying the third rule, which is q should not be equal to 0 here, because your q is equal to 0, leading an irrational value, a non-rational number. Now, the next thing is fraction and decimal. Fraction and decimal are the two sides of a same coin. They both are used to represent a certain part of a very complete number. For example, fractions are always written on the format of p by q, where q is a complete number, and p is a part for which we are talking about. And in decimal, this complete number is represented as unity. This complete number is represented as unity, which is basically 1. For example, suppose making a square, and in this square, this particular portion colored it. So I'm going to ask you that what is the part of this particular object is colored? The total part of this object which is colored, it's 1 by 4. That one part of the 4 total parts is colored. Now if you have to represent it in a format of decimal, this complete object, this complete numbers is being assigned as a unity. Now 0.25 is the data representing this physical value. So 1 by 4 can also be written as 0.25, and 0.25 can also be written as 1 by 4. Both of them are representing this physical existence. Now, next thing we have to understand is irrational number. Irrational number. So a number which is not rational is irrational. Irrational numbers doesn't have to obey this p by q rule. That means these numbers cannot be written in the fractional format or p by q format. Example, the value of pi, like it's 3.1415, and it goes so and so and so and so. You cannot write it in a format of fraction. You cannot find a perfect fraction for this value. We do write 22 by 7, but it is not the actual value leading to this pi value. This pi and this 22 by 7 is totally different thing. This is related to circle, and this is a certain value which is close to 3.1415. So this is irrational number. Now, the last thing is unit. Unit are nothing but the adjectives of numbers. For example, if I'm going to ask you give me 2 or give me 3, so you're going to ask me what 2, what 3. You want a certain unit to define this. Give me 2 chocolates, give me 1 bike, give me 3 toffees. These are units. To make two numbers equal, we have to make sure that numbers and units should be equal to make numbers in equilibrium state. For example, suppose 2 centimeter cannot be equal to 2 meter. Here we can see the numbers are same but the units are different. Similarly, 200 centimeter is not equal to 2 centimeter. The numbers are different, yet the units are same, but both of them are not equal. To make a number or a physical quantity equal, we have to signify it as both number and unit as a similar existence or in an equilibrium state. Now this is a state where both number and the units are same. Remember, units are very important to understand the physical quantity and the existence of physical quantity and the measurable part of that physical quantity. For example, 2 liter has different measuring value, 2 centimeter has different measuring value, 30 degrees centigrade has different measuring value. Now, 30 degrees centigrade temperature is a scalar quantity. Now, this 30 degrees centigrade doesn't have any direction, like this temperature is going into which direction? North, south, east, west. But suppose we're having a rod. Now this rod, at one point of this rod, one end we're having 70 degrees centigrade temperature and at the other end we're having 30 degrees centigrade temperature. Slowly, we are going to see heat flux. We're going to observe heat flux, which is temperature gradient moving from 70 degrees centigrade to 30 degree centigrade. Now this is a vector quantity. The temperature gradient, which is delta T, is a vector quantity because we can see the movement of temperature. But 30 degree itself, the temperature itself is not a vector quantity, it is a scalar quantity. So we have understood the difference between numbers and units, and in the next lecture we are going to understand the next topic. And please solve the module. The link of the Telegram channel will be pinned in the comments, and as I've said at the end of the video, good night.